Welcome to our Functionally Evaluation course. My name is Charles D. Francesco. Dr. Robert Onesta assisted me in writing this course. We hope that you enjoy it. Objectives: learn the anatomy of movement, learn the basic physiology of movement, learn basic testing principles to determine appropriate individual course of action for each client. This is important because you want to make sure that everything you do is on an individual basis and you are looking at each person based on what their needs are and what their activities may be. Structures: bones, joints, fascia, muscles, nerves, and blood vessels are all structures in the human body. Bones. The human body contains 206 bones. At birth, you have about 300 bones, but as you get older, these bones fuse together. There are 5 different types of bone: long bone, short bone, flat bone, sesamoid bone, irregular bone. Anatomical landmarks of bone. It is important to understand the basics here because this is where muscles originate and insert into the skeletal system. A tuberosity is a large bump on the bone. It's usually pretty wide with a rough surface. An example of this is the ischial tuberosity in the pelvis. A tubercle is a smaller bump on the bone. An example of this is the tubercle in the humerus. A process is a projection of the bone. An example of this is the transverse process of the spine. All 3 of these prominences usually serve as an attachment for soft tissue and structures, like I mentioned before. Spine or spinous process are typically longer and thinner projections of bone, unlike any other prominences in the body. Condyle: rounded surfaces at either end of a long bone. Epicondyles: small bony knobs that sometimes appear just above the condyles of a bone. Fossa: a smooth hollow surface on a bone. Usually this functions as a source of attachment for other structures. A facet: a smaller, flatter, smooth surface that functions as a source of attachment for other structures. Notch: an area of the bone that appears to be cut out and allows for the passage of other structures such as blood vessels or nerves. Here we have the different types of vertebrae: cervical, thoracic, and lumbar. This slide breaks down the anatomy of each of these types of vertebrae. I suggest that you study this and memorize it. Let's talk about joints now. A joint is an articulation, a place where 2 or more bones come together. There are 2 major types of joints: diarthrodial and synarthrodial. Diarthrodial joints, also known as synovial joints. These are the joints where the most movement occurs, divided into 6 different subdivisions by their shape: hinge, ball and socket, irregular, condyloid, saddle, and pivot. You'll see a diagram on the side here to give you an idea of each of those joints. We'll get into that later. Hinge joint. This joint has one concave surface with the other surface looking like a spool of thread. The elbow joint is an example of a hinge joint. Ball and socket. This joint consists of the rounded head of one bone fitting into the cup-like cavity of another bone. It is capable of movement in 3 planes of motion. Both the hip and the shoulder joint are examples of a ball and socket. Irregular joint. This joint consists of irregularly shaped surfaces that are typically either flat or slightly rounded. Carpals are an example of an irregular joint. Condyloid joint. This type of joint consists of one convex surface fitting into a concave surface. It is similar to the ball and socket, but the condyloid joint is only capable of movement in two planes of motion. As an example, we will use the interphalangeal joints. Saddle joint. This type of joint is often considered a modification of the condyloid joint. Both bones have a surface that is convex in one direction and concave in the opposite direction, like a saddle. These joints are rare, but the best example is the basal joint between the wrist and the thumb. Pivot joint. This joint consists of one bone that rotates about the other bone. An example of a pivot joint is the radius bone rotating on the humerus. Synarthrodial joints. Unlike diarthrodial joints, synarthrodial joints have no separation or joint cavity. There are three subdivisions of synarthrodial joints: sutured, cartilaginous, ligamentous. Sutured joint. This joint has no detectable movement and appears to be sewn together like a seam in clothing. The bones of the skull are the classic examples of a sutured joint. Cartilaginous joint. This joint allows some movement, but cartilaginous joints, other than those of the spinal column, do not play a major role in movement. This type of joint contains fibrocartilage that deforms to all movement between bones and acts like a shock absorber between them. Ligamentous joint. This joint ties bones together where there is very limited or no movement. The joints between two structures of the same bone, like between the shafts of the forearm and the lower leg, are good examples of ligamentous joints. We included a duplicate of this diagram so that you can see this larger version more clearly. Muscles. Muscle tissue is often categorized into three types. Smooth muscle, which is the internal organs and vessels. Cardiac, which is unique to the heart. Skeletal, which is the muscle tissues that causes the voluntary movement of bones and joints throughout the body. Skeletal muscle has 7 types. Fusiform, which is a muscle that has the shape of a spindle, that is wider in the middle and narrows at both ends, has a greater range of motion, but is limited in strength. Biceps brachii is a good example. Quadrate, a muscle that is square-shaped with directly parallel fibers. An example, pronata quadratus. Triangular, a wide origin that converges to a narrow insertion resembling a triangular shape. Good example of that is the infraspinatus. Unipinnate, fibers are on the same side of the tendon. An example would be the lumbricals. Bipinnate, fibers on both sides of the central tendon. Rectus femoris is a good example. Longitudinal, parallel fibers consisting of tendinous intersections that run perpendicular to the direction of the fibers. Good example of this, rectus abdominis. Multipennate, central tendon branches with a pennate muscle. Good example would be the deltoid. This slide just shows examples of what each muscle looks like to give you an idea of how the fibers run. Most skeletal muscles are either fusiform or pennate type fibers. General structure of skeletal muscle. Skeletal muscle is encased by a form of connective tissue known as the epimysium. Within the epimysium are numerous bundles of muscle fibers that are individually wrapped in a fibrous sheath known as the perimysium. Within the perimysium are muscle fibers which are in turn enclosed in a connective sheath known as the endomysium, which would be the deepest layer. Below is a diagram to give you an idea of what this looks like. A muscle fiber consists of a number of myofibrils, which are the contractile elements of the muscle itself. Individual myofibrils are enclosed by a viscous material known as the sarcoplasm and wrapped in a membrane known as the sarcolemma. Lengthwise, myofibrils consist of bands of alternating dark and light filaments of contractile protein known as actin and myosin. A myofibril is divided into a series of sarcomeres, which are considered the functional units of the skeletal muscle. Sarcomeres contain an I band. This is the light-colored portion where the protein filament actin occurs. Sarcomeres also contain an A band. This is the dark-colored area where the protein filament myosin occurs. A sarcomere is the portion of a myofibril that appears between two Z lines. There are two primary types of skeletal muscle fibers, fast twitch and slow twitch. Most muscles contain both types of fibers, but depending on heredity, function, and to a lesser degree, the type of training, some muscles may contain more of one type of fiber than the other. This is going to help determine what somebody would be really good at. If genetically they have more white fast twitch fibers, they're going to be stronger than somebody who has more red slow twitch fibers. Fast twitch muscle fibers are large, white, and appear in muscles that are used to perform strength and power activities. Slow twitch muscle fibers are smaller and darker red than the fast twitch fibers. They are slow to fatigue and are prevalent in muscles involved in performing endurance activities. The reason for the color difference is the red fibers have more blood flow. That's why they have more endurance. While it is important to understand all the muscles in the body, here we highlighted some of the more important posterior muscles you'll need to understand for this course. Here is another diagram of an anterior view showing the muscles of the trunk and the upper hip area. Again, it is important to understand all the muscles in the body, but for the purpose of this course, we're going to focus on the trunk. Nerves. For the purposes of this course, we're going to go into just the basics of the nervous system. The nervous system is one of the most complex systems in our body. It is made up of three main categories: central nervous system, peripheral nervous system, autonomic nervous system. The central nervous system consists of the brain and spinal cord. This system is in charge of controlling most of the body's functions and the mind. The peripheral nervous system consists of 12 pairs of cranial nerves and 31 pairs of spinal nerves. This system is meant to help connect the organs and limbs with the central nervous system. The autonomic nervous system is divided into two parts: parasympathetic, which is for rest and digest, or the sympathetic, which we know as fight or flight, is involved in the involuntary function of the organs, glands, and smooth muscle tissues. The nerve cell, or neuron, consists of a cell body and projections from it. These are known as the dendrites and the axons. The dendrite receives information from the surrounding tissue and conducts the impulse to its cell body. The axon conducts the nerve impulse from the cell body to the muscle fibers. Motor nerves carry impulses from the central nervous system to target muscles via the peripheral nervous system. Sensory nerves carry impulses to the central nervous system from the peripheral nervous system. The blood vessels bring nutrients and oxygen to the muscle tissue and carry away waste products. When the heart pumps, blood moves through a huge vascular tree consisting of arteries, arterioles, which are smaller arteries, capillaries, veins, and venules, which are smaller veins. The arteries and arterioles distribute blood to the tissues. Capillaries are the exchange centers where nutrient, oxygen-rich blood enters the cells and waste leaves the cells to be carried away. The veins and venules collect the blood from the capillaries and return it to the heart. The veins contain small valves that permit blood to flow in only one direction. Because the veins have to work against gravity, the skeletal muscles act as a muscular venous pump that squeezes blood upward past each valve. Movement is essential for healthy circulation. This is why we want people that have poor circulation to exercise more. Bursa. Bursa is a sac-like structure that contains lubricating fluid to reduce friction between tissue of the body. It protects the muscle, tendon, ligament, and other tissues as they cross the bony prominences described earlier in this course. The bursa allow tendons to glide directly over bone without being worn away over time from friction. When you hear people say they have bursitis, this is what they're talking to. That sac has become irritated, inflamed, so it causes pain. The fascia. Fascia is a form of connective tissue that covers, connects, and supports other tissues in the body. Fascia connects every structure in the body. It is a major communication network. The fascia transmits mechanical energy throughout the body. Fascia houses mechanoreceptors that provide the brain with sensory and proprioceptive feedback. This system plays a significant role in coordination of muscle activity. There are different types of fascia. Superficial, which is related more to the skin, deep, which is related more to the muscles, visceral, which is related to the organs, and parietal, which is related to the interabdominal cavity. Fascia is primarily made of collagen and runs through the body, giving it stability and the ability to transmit force through it. Fascia is very detailed and a very deep topic. We're only touching on it in this course because it is actually a course within itself. We suggest reading the book Anatomy Trains, which will really give you the most information possible on understanding the fascia. A motor unit is defined as a motor nerve and all the muscle fibers it supplies. The structural parts of the motor unit are the motor nerve and the muscle fiber. All of the motor units together are referred to as the body's neuromuscular system. The motor unit functions by the impulse from the motor nerve crossing the synapse at the myoneural junction. This activates the release of calcium through the sarcoplasmic reticulum and transverse tubules, causing the cross bridges of the myosin protein filament to contact the actin protein filaments. Movement of the actin filaments towards the center of the sarcomere is then produced, thus shortening the sarcomere. Motor units differ widely in the number of muscle fibers innervated by one motor nerve. The ratio of muscle fibers per motor nerve can range from as low as 10 muscle fibers to as high as 2,000 muscle fibers per one motor nerve. Here are some refreshers so that when we talk about movement, it is easy for you to understand what we are doing. Anatomical locations: superior, above, inferior, below, lateral, away from the midline of the body, medial, towards the midline of the body, anterior, the front of the body, posterior, the back of the body, proximal, closest to, distal, furthest away. When talking about human movement, it is imperative that you understand the basics of the planes of motion. Human movement takes place from a starting position. This is known as anatomical position. An axis is a straight line around which an object rotates. There are three planes of motion: sagittal, transverse, also known as horizontal, and frontal, also known as coronal. Sagittal plane passes from the front through the back of the body. It creates a left and a right side. A good example of this is a sit-up. Transverse or horizontal plane passes through the body horizontally to create top and bottom segments of the body. A good example of this would be a horizontal chop. Frontal or coronal plane. This passes from one side of the body to the other, creating a front side and a back side. A good example of this would be a shoulder press. And you'll see in the example below that it looks like sheets of glass dividing the body. A good way to know what plane of motion you're in is to look at it as you're staying along the axis of the glass. Don't break the glass. So see how a sagittal plane exercise wouldn't break the glass like a sit-up or bending forward, but a rotational one would break the glass in the sagittal plane? You can see that with the diagram if you look at it and pretend those are sheets of glass. In the sagittal plane, the fundamental movements are known as flexion and extension. Flexion is the decreasing of an angle formed by the bones of a particular joint, such as a bicep curl. You are flexing at the elbow. Extension is the exact opposite, increasing the angle formed by the bones of a particular joint. A good example of this would be a tricep pushdown, the extension at the elbow. In the frontal plane, the fundamental movements are abduction and adduction. Abduction is movement away from the midline of the body, such as when you sit in a hip machine, when you open your hips, that's hip abduction. Adduction is the exact opposite. It's movement towards the midline of the body. Same machine, when you sit in this hip machine, you squeeze your legs together, that's adduction, bringing closer to the midline of the body. In the transverse plane, the fundamental movement is simply rotation. There is internal rotation and external rotation. Internal rotation is rotation towards the midline of the body, such as when you do internal rotation for your shoulder with a cable machine. External rotation is away from the midline of the body. So, same exercise with the cable machine, externally rotating the shoulder, going the opposite way. Functional evaluation tests are meant to test a client's balance, coordination, postural control, muscle activation patterns, strength and endurance, and flexibility. Every test is an exercise, and every exercise is a test. For the next portion of this video, Dr. Anesta will be taking over and voicing over all the videos to describe each test. You will see in this next section that the video comes first with the voiceover, and then the slide following is just a summary.